This lesson is about performing arithmetic operations on functions. Have a look at this blue line here. It represents the graph of the function f of x equals 0.5x plus 1, and the green line represents the graph of the function g of x equals 2x minus 3. Points b and c belong to those lines, and they have the same x, which happens to be 5 at the moment. But they have different y's, of course, because they belong to different functions. But have a look at the red point A. For the same x-coordinate, it's got a y-coordinate that actually comes from the green and blue y-coordinates. Can you guess what operation was done to them to get 10.5? Of course it was addition. And I can change the x-coordinate over here with this slider. As I change the x value, you can see that that relationship is maintained. No matter how much x is, the y-coordinate for the red point is the sum of the y for the green and the blue. Keep your eye on the red point. As I change the value of x, what kind of function is that red point forming? You can actually see by clicking on the resulting curve that it does in fact form a linear function. What we've done is we've just added the blue function to the green function. We could have predicted that the answer would be a linear function by looking at the algebra involved. Because if we took the algebraic expression for f of x, our blue y, and add it to the algebraic expression for our green y, we would add the like terms and algebraically simplify it to get 2.5x minus 2, which is of course just another linear function. Think about that algebra as you think about this question. Will a linear function added to another linear function always result in another linear function? For that matter, what would happen if instead of adding two linear functions, you were to subtract two linear functions? Well, we can check that out right away. I've got it set now so that the red point now has a y-coordinate that is the result of the blue minus the green instead of the blue plus the green. And again, I can change the value of the x so that you can see that that relationship is once again always maintained. So if I were to hide the blue and the green so that you can keep your eye on the red, it certainly looks like it's forming a linear function. We can see that it certainly is a straight line, and if we check out the algebra, by subtracting like terms, we end up with another linear function, negative 1.5x plus 4. Now I've changed the operation happening between the blue and the green function. Have a look at A's y-coordinate now compared to B and C. Think about what operation must be happening between the blue and green functions now. It must be multiplication. Now what happens algebraically when you multiply an expression like this by an expression like this? What kind of an expression do you end up with? Use that to predict what kind of function A is going to form as I move the x slider around. In fact, it forms a quadratic function. And finally, it's no surprise that the last operation I'm going to do is division. Just check 3.15 divided by 5.6. Yeah, it sounds about right. What's surprising here is to see what kind of a curve you end up with. That's the result of dividing a linear function by another linear function.